we use altogether another data structure, what we call it is the file based data structure, which contains the 3 entities, correct now, or any like the node. So we still refer it as a node. We call it whenever 2 or more nodes are adjacent, then we just draw a line, we call it the segment. But here the segment is just a line from the one point to the other. Here the segment is not that, it contains a number of other features. Because in the map or the road you see, it is not always a straight line. If you are joining the point, the Madhuban Chowk to some other chalk over there, this road is not always a straight line. It is a curved one. So whenever you to represent this curved line, you need some intermediate point in between. Those who have studied the computer graphics, what we call it is the knot vector. To maintain this, the curve, the more and more curved the line is there, more and more such intermediate points will be required. So those intermediate points are also stored and written over that. So that is the data structure we use over that, correct now? And the graph, you forget about that, this is all the theory. This is the one, correct now? Let's suppose we have to, the advantage is that, suppose the intelligence agency, I hope all of us have heard that there was a stampede in the Allahabad yesterday. तो हो गया, बहुत जगह हम लोगों का कंट्री ऐसे ही ओपन है, टेररिस्ट अटैक भी होते रहता है. तो इफ द इंटेलिजेंस एजेंसी गेट्स प्रायर इंफॉर्मेशन कि यहाँ सर्टेन एरिया इज सेंसिटिव, and that information has to be shared between this the law and order maintaining authority. Those information are to be passed secretly and privately. So how to share the information in such a way that only concerned person should know, nobody else. One of that, suppose the area is communally sensitive, high alert from 11 am to 3 pm, and this has to be passed from the one, suppose police headquarters to some area concerned. And they don't want to pass this message. But what will be the ideal way? Instead of what is the area? Area is also not written. So if you take the map of that area and hide this information in that map and let it pass. So once it arrives, means a message is related to that geographical area. The area is now known because of this map. And what is that message? Message is this one, extract that message. So in that way, that graph or the map information helps a lot. There is the other application like the watermarking we have discussed, correct now? But this is the another one, you can use the map to convey the location as specific secret information. So get the location in form of the map, hide the information into that and just let it pass over there. So this one, now after removing all the spaces, punctuation mark, that is the standard, we use it, correct now? Treating all characters in the uppercase, the ASCII code in the hexadecimal for the message aim is this one. ASCII code in the hexadecimal, all again, nibbles. Binary string representing the message. So all this is the binary string, correct now? So whatever the message is there. Now this is the map of suppose a certain area. Rearranged binary. So what do we do with it? Can I start? Let's see the technique, the very simple. Whenever you have map and the graph, then it will have a certain number of nodes. Suppose this is the 100, correct now? Then each node, if you want to have a number, 1, 2, 3, 4, 5 and so on, to represent that, you need log n bits, am I right? If it is 100, they need the 7 bits, am I right? To represent the value from the 1 to 100. Yes, no? Minimum 7 bits will be required. Up to 128 it is the 7. So 100 is anything between 64 to 127. You need to have this 7 bits. Now, number of nodes, suppose it is the 100. So you need 7 bits to represent the node. It is number from 1 to 100. Now what? Take this first 7 bits of the message, convert this into the decimal. So you will be getting some decimal value which will be possibly representing some node number of the graph. I hope you are getting the point, correct now? Because get the first 7 bits from this message bit stream and they convert into decimal. Decimal, so you will get some number. Possibly it will be between 101 to 127, it could be. But we are saying, suppose it is between 1 to 100, then it will be representing some of the node. The embedding will start from that node onward. So this is the starting node of the embedding. We have not done anything. We have not changed the name of the node. We have not replaced any bit of that. Only relationship. This is the node from where the embedding starts. A starting node, we will write it someplace. Now you see, which is the next adjacent node, correct, of this one. So possibly a node has a 4, 5, 6 adjacent nodes, maybe one, and the graph it will be very difficult to find the dangle nodes, correct now? So this is all the closed circuits. So whenever the map you are going to get, almost it will get the closed polygon, correct now? So in that case some nodes will be the adjacent one. Say what is the number it is going to be. So what you do here, it is done in the see the text message, this one, the first 7 for example, you take and convert this into a number, embedding will start from that, then you see the next 7, this will again give you a node number. Now this node may be adjacent to the first one, it may not be adjacent, both possibilities are there. We cannot always assume that whatever the next bit is going to represent a node, this node is always going to be adjacent. If it is adjacent, no issue, continue. If it is not adjacent, you just use this as the sliding window. Then you move this by the 1 bit to the right, correct? See whatever the next 7 bits, if it is representing some adjacent node, if yes, use that, if not, again shift 1 bit and you get the next adjacent node. Now what about this bit stream which are coming in between, like the here, which is not bold, 10101, correct now? This 5 bits have been skipped to find the next adjacent node. Now this is going to be embedded in the segment, because this segment contains a number of intermediate points, correct? So this intermediate points, and in this is all the map, we call it is not the raster data, we call it is the vector one. So each intermediate point has the location in the x and y, correct now? So this is x and y coordinate, very simple. We find this, the 0, 1, 101, x, y. What is the Hamming distance of this one is going to be? If the Hamming distance is odd, it will correspond to the 0. If it is even, it will correspond to the 1, or either way you take it. Now most of the time, if it is there, if it is matching, if it is the odd and the corresponding bit is 0, you don't have to do anything, move ahead. The first bit is embedded, and so on, so on. And this is the way this is hidden. Ultimately, sometimes you won't have to hide any bit in the segment. Sometimes you may have to have the 5, 6, 7, something is given over there. The last one, so the much more. The here, the number of segments should have the sufficient number of intermediate points. In fact, whenever you just see the GIS spatial data map, whatever we call, in the one segment you get in the 500 such intermediate points, because to maintain a larger road is there, number of curvature is there, and there is no junction in between. हर जगह चौराहा नहीं आता, नोड देने की जरूरत नहीं है. Only we have to maintain the curvature. There is no need of node, only go for the intermediate point, and so on. And that you get the redundancy, you can hide it from the center to that. I hope there are much more, but this is the another question comes in the segment, because the number of bits hidden in the different segment will be different. Then how to indicate to the recipient which segment contains how many bits, because sometimes this segment may not have any. The node 1 and the node 5 as adjacent, here you have hidden the 3 bits, 5 to 7 there are the 5 bits, 7 to 9 0 bits, because they both are adjacent and you have got such a block. How to indicate, pass this message, particular this one contains 3, 5, because that has to be conveyed. Only then the message will get retrieved over there. So there is a corresponding file, the file based data structure, in which we use one, what is called, this is the key value, to mark the indicator, read the information from that. So at the time of passing the information, it will go a graph, the completely exported graph, the data structure, export that. So those who have a little bit of the spatial data knowledge will appreciate that. So this is the one another way of using graph as a cover for hide information, and it is used currently for the two basic purposes. One, for the sharing of the information in the locational based information, and then watermarking of the spatial data. Very well, this technique is also used for the watermarking of the spatial data. A lot of paper is there, correct now? So those who are interested can very well see this is all the analysis and how it can be used, how the future direction it is going to be. So many works and you can use for that, like normally in the LSB steganography, to start with, whenever the student of the steganography starts this technique, they start with the concept called the LSB, least significant bit, because if you disturb it, it will hardly change the characteristic of the digital canvas, correct now? The LSB, but sometimes it is not selected in the sequence manner, first byte, second byte, third byte, or the first, fifth and the second, but these are selected randomly. If you select randomly at the embedding it, how to convey this random information to the receiver end. If you use some mathematical formula which generates the randomness and you share that mathematical formula, that will be working as a key. The one is that a recursive or explicit mathematical function may be derived to divide the image based on the cover, image based cover in the different blocks of the different size. Like we have studied the two algorithm where we are dividing the block in the fixed size k, k, k. Why uniformly divide that? You can say the first block is going to be of the 5 block, second is going to be of the 50, third is going to be of the 17. There's such a randomness. The more and more randomness is added, more and more such the embedding algorithm will be confused to the hacker or the stag analyst. Correct now? This is the third one, this is spatial data, just to protect it, like the watermarking and the fingerprinting, a lot of work is going on. JTA, the graph theoretic approach. Now, what about the third one? What we have done is, I think whatever we have worked, 60% to 70% information gets hidden in the node relationship only, but still we get 20 to 30%, 35%, which needs to be embedded in the segment. The more and more work if you do, that is the 30-35% can still be reduced and can be minimized, so that no information should be hidden in the segment. So only the relationship will work and all the information may get embedded in the node itself, or just by nagging location of this, what we call the editing of the spatial data. Just dislocate something, change the place of the node, such a minute way, because whenever the map we see, the entire earth map is on the A4 size paper, correct now? Now you see the scale which we are using, thousands of kilometers on the ground, we are representing by 1 pixel on the paper. So if we change the location a little bit over there, you are hardly going to make any change, but for the hiding purpose, it will give you the sufficient number of this value. Now another area is the graph isomorphism. Those who have studied, this is a very wide area, and this isomorphism, how to find this graph, they use this information, hide this information using this graph, and the extract using this isomorphic one. A lot of work is also going on there, how to use this for the public key, like we use, we are embedding using one key, private one, the encrypting, and the decrypting using the public one, correct? Or the encrypting using the public key and the concerned person is decrypting using the private key, the reverse one, and the both key are not equal. Similarly, if we use this isomorphic map, they use this one map and select one of the thousand of isomorphic either. This also a lot of work is going on. So these are the area, and I hope people must have enjoyed this, the basic concept of the graph theoretic approach. Lot more work is done in the watermarking, fingerprinting, and so on. Correct now? Okay, thank you very much for listening so patiently. Right now.